All right. Hello, everyone. Welcome to MOS Live and good afternoon. Today we're talking with Museum of Science educator all about stars. My name is Emily. My pronouns are she, her, and I'll be keeping an eye out for all of your questions today. Thank you for those of you who are tuning in on Facebook or YouTube, but please note that we are not able to share your comments with our educator at this time. For everyone here on Zoom, just press the Q&A button at the bottom of your screen to submit your questions. Don't forget to include your name and age if you'd like a shout out. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show captions. I would now like to invite my educator to come on screen, introduce themselves, and we'll get started.
Thanks, Emily. Hi, everybody. My name is Katie. My pronouns are she and her, and today I'm going to be giving you a classic tour of the nighttime sky. So we're going to talk about all of the different things that you can see up in the sky tonight. So I will switch on over to our software today. So I'm using a software called Stellarium. It is a free open source software that you can download online if you go to stellarium.org. And we will have that link for you at the end of the program if you are interested in checking it out on your own. What's really cool about it is that you can set it to any time of day. Right now I have this set to 10 p.m. tonight, and we are viewing from Boston. So you can also change that setting and view from anywhere you'd like on the Earth or even other places in the solar system, which is pretty cool. So I have us starting out looking in the northern part of the sky. Generally, when I start a star tour, I like to start in the north just because there are a lot of really familiar groups of stars in this part of the sky. And you can actually use some of these groups of stars to find other groups of stars. So why don't you just go ahead and take a few seconds to look at this part of the sky and make some observations. Is there anything that you recognize? Do you see any particular constellations or objects, planets, things like that? And go ahead and type that into the Q&A.
While we're waiting for some observations to come in, I'll say that I certainly noticed some of these objects look bigger and brighter than others. And we have one person here, Sharon, saying they see the Milky Way, maybe.
Yeah, those are both really good observations. And I will note that in this program, since we're using a computer screen to view it, any of the stars that you're looking at, because some of them look really big in size, but those are actually indicating objects that are a lot brighter. So they're not necessarily bigger in size, but they are a lot brighter, which is different from if you were to just look at the nighttime sky out in your backyard, because at that point you're seeing just points of light, and some of those points of light are brighter than others. So in this program is kind of like a hacky workaround. They're making objects that look brighter, bigger. So that is one thing to note as we move through the sky today. And yeah, so you can see the Milky Way over here, kind of starting low in the northwestern west part of the sky. And then it kind of, if we zoom out, you can see it arching over the entire sky. So the Milky Way is our galaxy. And so you can kind of think of like our cosmic address, right? So we live on the Earth. We are inside of the solar system, which is composed of the sun, 8 planets, and we've got the asteroid belt and the Kuiper belt and a few other, like moons, few other types of objects in there. But that's just our solar system. So you can kind of think of that as like maybe your neighborhood or the town that you're from. And then the entire galaxy is like all of North America, if North America had 300 billion towns in it. So we are just kind of one solar system in the Milky Way Galaxy, which is our galaxy. And since we live inside of it, we're looking at it edge on. So we're seeing this really dense kind of part of our Milky Way. That's where all of the gas and dust and stars, a lot of that material is kind of confined to this plane. Now, all the other stars that you see in the sky that are not in the area of the Milky Way, they're still inside of our galaxy. They're just a lot closer to us than the material that we see along that plane. And in order to see the Milky Way, you do want to go someplace that has very little light pollution. So away from the cities. Boston would definitely not be the best place if you're looking to see the Milky Way because of all of the light pollution. But there are plenty of places that you can escape to in the area, or, you know, if you're from somewhere else, just get really far away from cities, any kind of extra lighting, and you might be able to see the Milky Way. Awesome. Great observations. So I want to start with some groups of stars. So really low on the northern horizon here, we can see a particular group of stars that's pretty famous up here in the northern hemisphere, because where we're located on the Earth, we can see this group of stars year round. So pretty much if you are viewing from anywhere in the northern hemisphere, specifically in like the mid-northern latitudes or higher, you will see this group of stars all year long. So the farthest most star here, that's just right below the horizon, or almost below the horizon, marks one of the stars. And then we have 2, 3 in the handle of this group. And then we have 1, 2, 3, 4 in the bowl of this group of stars. So does anybody know what this is called?
Someone is guessing the Big Dipper.
Yeah, that's correct. It's the Big Dipper. At least that's how it is shown in Western astronomy, but lots of different cultures all around the world see it as different objects. But you'll notice that I've been saying a group of stars instead of a constellation. And that's because this particular group of stars is not a constellation on its own. It's called an asterism, which is exactly what I just said, a group of stars. That's very familiar. But it is part of a constellation that encompasses even more stars. So if you follow my cursor up in this direction, we kind of come to a point, and then we can also connect the stars down here. And you see there's 2 stars next to each other. We can also connect it down here and see another 2 stars. So the whole thing, and I can show you what it looks like this. So if you were to guess what this constellation is supposed to be, or what you think it looks like, go ahead and type that into the Q&A. And it doesn't have to be the right answer. It can just be whatever you think this particular constellation looks like.
You know, we had someone mention earlier. Oh, here we go. Here's some. It kind of looks like a Pegasus or a dog. Someone earlier said maybe a big bear.
Yeah, those are great guesses. It does kind of look like a dog, right? If this was like the head of the dog over here and legs. Pegasus is also a good guess because that is a constellation, and it is visible right now. So I can point that out to you later on, but it is a different constellation. And if you said a large bear or a great bear, you would be correct. This is Ursa Major, the great bear, and I can put the artwork up there. It's you kind of have to use your imagination. It's a bit of a stretch in order to actually see this bear. But once we put the artwork up there, that helps quite a bit. And you'll notice that it has a very long tail, which is pretty interesting because last time I checked, bears have short, stubby little tails, not long ones that they could wag at you. But there are lots of stories to go behind the constellations, and plenty that explain how the bear got its very long, bushy tail. All right, so I'm going to take that down just so it's easier to see. And let's use the Big Dipper to find another constellation. So we're going to take these 2 end stars here and just connect them together and point them in this direction. And so the first star that we run into is where we're going to stop. And just for reference, it's about 5 times this distance. So if you're looking outside and you find the Big Dipper and you want to find this next constellation, just go about 5 times this distance. All right, so this is the first star that we run into, or first bright star that we run into. And that brings us to the next constellation, because this star is the end of the Little Dipper, which is right there. Now this constellation, or rather this group of stars, is also a constellation. The Little Dipper is also known as Ursa Minor, which you might be able to guess from the other constellation we talked about, Ursa Major, that this is a little bear. And I will show you the little bear because it's very cute. And it has an even longer tail and bushier and longer. So this is the baby bear. And what's really interesting about this star is not necessarily because it's really big or bright, but that it's actually a very famous star, probably the most well-known star, because it is Polaris, also known as the North Star. So if I click on it, you can see some of the information up here. It's got lots of different names, and we can see that it is about 432 light years away from us. Now, the reason that this star is so famous is because it's always in the north. So because the Earth spins, stars, the sun, objects in the sky that are in space, they tend to look like they're spinning around us. But that's just because the Earth is rotating. So as the Earth spins, all of these stars kind of look like they're moving in a circle around this point in the sky. And so this point never moves because it happens to line up perfectly, or almost perfectly, with the Earth's axis of rotation. So if the axis was an actual stick going right through the globe and you wanted to stretch it all the way out into space, you would eventually run right into this star. And if I put this grid on, it's called an equatorial grid, you can see that this spot marks the North Pole, or the northern axis of rotation, and it pretty much just lines up with the North Star. So as the Earth spins, all of these stars just kind of spin in these circles, but that spot always stays fixed. All right, so that's a little bit of what's going on in the northern part of the sky. Now we are getting into the late fall, early winter time, which means some of my favorite constellations are showing up over in the east. So I'm going to shift our attention over to this part of the sky and talk about some of these constellations. But first I'll pause and see if there have been any questions so far.
Yeah, we have a couple of them. I think I'll start with this one, which is just how do you know where the constellations are and how do you find them?
That's a really good question. So the constellations are pretty much completely made up. They've been made up by humans for a very, very long time. And so these particular constellations that we're showing you today are mostly the Greek and Roman constellations. And once people found these patterns in the sky that eventually kind of stuck and are now the official ones that we use to map the sky, we can actually measure their coordinates. So kind of like how on the Earth we measure latitude and longitude, and that's kind of how we pinpoint a certain place or location on the Earth. We can do the same thing with the stars. It's a little bit different because because of Earth's rotation, it looks like the stars are moving around us. But relative to each other, the stars relative to each other, they don't move. So like Ursa Major and Ursa Minor will always be in this configuration. They might end up looking like they're over in this part of the sky as it gets later in the night, or at a different time of the year. Their positions in the sky might look like they've changed, but the position relative to each other of these stars will always be the same. So once you find a constellation and you know where to look for it, then you can kind of predict where it will be at certain times, and that's how you find it. So it's like they serve as a map for the night sky. Was there a second part of that question that I missed?
No, I think you covered it.
Okay.
And then we just have another question. A lot of people are curious about the different types of things that we might see looking at this here. One of them is asking, can we see the moon?
Yeah, that's a good question. So let's look around the sky right now. I don't know what the phase of the moon is right now. So it's possible that it might not be visible right now. It doesn't look like, sorry, I know this is a very weird view of the night sky, but it doesn't look like the moon is visible right now, which means that it is in either a crescent phase or a new moon phase. So basically those phases of the moon are the ones where the lit up side of the moon is mostly the side that's not facing the Earth. So that means we really can't see much of the moon. And those phases happen during the day for the most part. So at nighttime, you can sometimes see a full moon or maybe a quarter moon or a gibbous moon when the moon is almost full. But if you can't see it at nighttime, it generally means that the moon is not very visible at all. So I don't see it right now around 10 o'clock, but you can see it if you were to fast forward time and search for it in this program. You'd eventually find it.
Thank you. Maybe one more that you can answer quickly.
Yeah.
Are there going to be meteor showers tonight?
That is a good question. So during this time of the year, there's almost always a meteor shower happening somewhere at any time. But some meteor showers are much more populated than others. So some of the more prominent meteor showers are the Perseids, which happen in August. So that's going to be the brightest meteor shower that you would see the most meteors in the atmosphere. Right now, I'm not actually sure if there's one going on, but if there is, it's probably not very bright. But if you go outside and you look up at the night sky, there is a very good chance that you will catch a shooting star at some point in the night, because they happen fairly frequently, even if it's not during a meteor shower. So as long as it's clear, your chances are good of seeing one. All right, awesome questions. I'll take a few more at the end, but right now I wanted to shift our focus over to the eastern part of the sky. So these constellations are rising because they are part of the wintertime constellations, and we'll be seeing them really high in the sky as we move through the next few months. So it's good to keep an eye on them now and kind of track their motion across the sky over the next weeks to months and into the springtime. So why don't you go ahead and type into the chat anything that you recognize from this angle. There's one constellation in particular that I know is a very famous constellation because it's very bright.
Just waiting for some answers to come in. I wish I knew my constellation so I could help, but I don't know. Oh, one person guessed Orion the Hunter.
Yeah, so Orion is visible in this part of the sky. And also I do want to mention that if you don't know the answer to any of my questions, it is totally fine to say, I don't know, or just put in a question mark, because that's one of the awesome things about science, right? Is that there's a lot of stuff that we don't know. So that's why we ask questions and continue to do science. So it's important. Yeah, you can find Orion in this part of the sky. He is pretty well marked by his belt. That tends to be the first thing that people notice about him, because he has a belt made up of 3 stars right in a row, and they look pretty similar in brightness. So red over here is his belt. And then from there, you can find the rest of the constellation. So if we come up here, we can find his shoulders. And then down here, he's got 2 legs and a very teeny tiny head, which is this star right here. And we can zoom in so that you can see it a bit better. So the stars that make up Orion are all very bright stars. 2 of them in particular are some of the brightest stars in the night sky. So one of them is over here, his, I guess it would be his right shoulder if he's facing us. This star right here is called Beetlejuice or Betelgeuse, depending on how you pronounce it. And this star is a red supergiant. So it's actually red in color, and it's really, really big, meaning it takes up a lot of space. It's much bigger than our sun. Our sun is an average star, so it's not, particularly extreme on one end or the other. But this star is much bigger than our sun, and it has a reddish color to it. And the name Betelgeuse actually translates to armpit of the giant, which is pretty appropriate for its placement in this constellation. And then this star down here, Orion's foot, is called Rigel. And this star is a blue giant. So it's actually blue in color. So as you can see, stars do come in different colors. And what do you think the color of a star can tell you about the star itself? So if you know, you can put it into the chat. If you don't know, you can say, I don't know, or type a question mark, either one.
We have some people saying, I'm not sure. A few guesses that it's the age of the star or how hot or cold the star is. Thinking like blue is like versus blue and red. Yeah, those are some of our guesses.
Yeah, those are great guesses. The age of a star is really interesting because sometimes if you know the size of a star or its temperature, what color it is, sometimes you can kind of tell what or how old the star is. But even more directly, just by looking at a star's color, you can actually tell its temperature or its temperature range. So if we're comparing Rigel, the blue star, with Beetlejuice, the red star, which of those two stars do you think is hotter? The red one or the blue one?
We have some guesses coming in. We have, I think blue is winning. We have some guesses for both, but blue is winning.
Awesome. Yeah, blue is the hotter one. And I know that's really counterintuitive and it's very strange because our sink faucets, right, tell us that blue is cold and red is hot. But when we're talking about energy, and especially objects that make a lot of energy or heat, especially stars, things that are blue are actually more energetic and much hotter than things that are red. So you can also think of like a flame. So stars aren't made of fire, but it's an okay comparison. You can think of like a blue welding flame versus a candle flame. The blue one is much, much hotter. So yeah, Rigel is on the order of tens of thousands of degrees on its surface, while Betelgeuse is closer to 3 to 5,000 degrees. So it's not cold by any means. You don't want to go up and give it a hug, but it is a lot colder compared to some of those really, really hot stars like Rigel. All right, one other constellation, or excuse me, one other of the objects inside of Orion, I guess it's many objects, but is this kind of fuzzy area right down here. So this kind of looks like a star cluster. Or maybe it looks like, I don't know, a giant star or something like that. But it turns out that this fuzzy area is actually a nebula. So you can see this if you were to take a look. Well, technically with the naked eye, you can spot this. You just won't be able to see it in much detail. It'll just kind of look like a smudge or a star cluster. But if you have a pair of binoculars or a backyard telescope and you point it at this part of the sky, then you'll be able to see this giant cloud of gas and dust that make up the Orion Nebula. And what's really cool about this particular nebula is that it is an area where stars form. So there are lots of different types of nebulas out there. There are nebulas that form after stars die. There are just, nebulas that absorb a lot of light or emit a lot of light. But this particular nebula is an area where stars form. So material clumps together and eventually kind of collapses and forms stars. So there actually are quite a few stars in this particular cloud. So we can also call them stellar nurseries, which is pretty cute, I think. All right, so we'll back up here. Are there any more questions that have come in?
Yeah, I think we can have a couple more questions. So one is asking, why do we draw stars the way we do if they're actually just a ball of flame?
That is a very good question. And I think that the reason we draw stars like that with the points is because of how stars look when we are looking at them through Earth's atmosphere. So stars twinkle And that's because the light from the stars are entering Earth's atmosphere, and then they get scattered around a little bit. So the stars don't actually twinkle. Like if you were out in space looking at stars, they wouldn't twinkle at all. But because of Earth's atmosphere, it kind of looks like they have these little points of light shimmering around, and that's because of the atmosphere. So that's my guess. But I'm not actually 100% sure, but that would be my guess.
Thank you so much. While we're at it, could you show the illustration of Orion?
Absolutely.
Thank you.
There we go.
And does the nebula that you just pointed to have a name?
It does. It's called the Orion Nebula, which is a very appropriate name.
Thank you. And then we just have two more questions. People are wondering where the Earth and Sun are in this kind of map that you're showing us.
Mm-hmm. So the Earth is, we're kind of like standing on it in this view. So if I back up a little bit, we'll go to before sunset. So this is the horizon, this is the ground. I have it set to be very plain. So it's not very exciting looking. And then the sun is right over here. So we're just looking later on in the night after the sun has set. So that's why you couldn't see it at all. And it looks like the moon is right over here. And if we zoom in, you can actually see the phase of it. So it's technically a crescent. It is almost first quarter. All right, so I'm going to bring us back to nighttime right now. And as we end the program, or if there are any other questions that come in, I'm just going to put up all the constellations so that you can see what the whole sky looks like. All right, we're going to take off single constellations and we can put them all up. And I do remember someone asking about Pegasus, or inquiring about it earlier. So he's actually right over here. This giant square is the easiest way to find him. And let me show you the direction he's in. So if you look toward the western sky, we're a lot later now. This is at 11:30, but if we back up just a little bit, we'll go to 10:30-ish. He's a little bit higher in the sky. So you can find that giant square. And then from there, you can find his head, and then his front two legs coming off this way. He doesn't have any back legs. They've just been cut off for some reason. So you'll just have to find the front.
Wow, well, thank you so much. It's such a beautiful picture to see all of these and to see everyone's interpretation
Absolutely.
of what they look like. So I'm going to turn my camera back on. That is really all the time we have for today. I know we didn't get to all of the questions, but please join us again sometime to see more of the night sky. And I'd like to invite Katie to say goodbye.
Bye, everyone. Thanks for joining.
Thank you so much. All right. Thank you everyone again for joining today. And thank you for being such excellent scientists and asking such great questions. I know some of you were asking what the software we were using was called. It's called Stellarium, and the link is here on the slide for you if you want to check that out. And once again, if you want to see more of our programs, please visit mos.org/MOS at home or follow us on social media. And if you've enjoyed today's presentation and you are able to, please visit the website on screen to support MOS at home so we can do more programming like this for you. Thank you, everyone. Enjoy the rest of your day, and we'll see you next time.